So continue where we left off at example 6, problem G. So in example 6, problem G, this is where we have f of x plus 2. So that means in place of x, we're substituting in x plus 2, right? So notice here, I replace all x's with a x plus 2. This right here, this square, do not distribute the power. This means that you have a binomial, right? So this is actually x plus 2 times x plus 2. So you have the complete FOIL, not distribute the power, okay? That's a big mistake that I've seen people make. So you distribute the power, combine like terms, and you come down to this. Now you can distribute the outside coefficient. So I'm now going to distribute 2. So when I distribute 2 to all the coefficients, I now have 2x squared plus 8x plus 8 minus 5x minus 10. Combine my like terms. And then my final answer is here. Okay, it's about following your order of operations and the rules that you already have or already know. So again, do not distribute because this is an operation taking place. So that means you have 2 binomials being multiplied. So we would FOIL, then distribute, then combine like terms. It's not a single variable. It's not a single term. It's x plus 2. So that means that you have 2 of these being multiplied together. It's not just x and y. Like if you had x times y squared, this would just be distribution of power. But if you have x plus y squared, the square means that you have 2 of the whole 2 binomials, not just 2 of the variables. Mm-hmm.
So that's why you didn't distribute the 2 first?
You couldn't distribute the 2 because you had to handle the parentheses first. Yep. And then you distribute. All right. Last, we have substitution of x plus h. This is going to come back to you like in calculus, but making sure you understand substituting in variables. So if I have x plus h, that means everywhere that there was an x, I replace with x plus h. And then I simplify. You treat it just as if it was a number and you simplify till you can't anymore. So notice here is x plus h squared. So that means I had x plus h times x plus h. I distribute. And now I'm down to this. And then I'm going to combine like terms. So in this situation, there aren't any like terms, are there? In order to be like terms, you have to have the exact same variables with the exact same power, right? So there are no like terms, so there's nothing to combine. So that's where I stop. Okay, just to summarize, these things are not the same. So notice when we substituted in x plus 2, is not the same thing as f of x plus f of 2. Those are 2 different processes, okay? Same thing here. When we substitute in f of negative x, it is not the same thing as negative f of x. Those are 2 different operations. This is affecting your independent variable. This is affecting the dependent variable, okay? So these are not the same things. Same thing here. Location of the coefficient matters, okay? Are you multiplying it to your dependent or are you multiplying it to your independent? And these just go back to your transformation rules. So when you look at this, you should think kind of like transformation. And we're going to go over transformation a little more, but review transformations a little more, but you should think of transformation and how each one of these play a different role of how the function looks. Okay. Next, so finding values using our calculator. So if I have f of x equals x squared, and I want to find f of 5 and 678, clearly in the calculator, this is all I have to plug in, right? If I'm using the calculator, I'm not going to spend a whole lot of time on calculator. So if I am allowed to use a calculator, what do? I plug it in as is and make sure I pay attention to the number of digits. Do you guys need to see me actually plug it into a calculator?
Yes.
Are we okay? You need me to plug this into a calculator? Brandon, get on my nerves. My computer won't even let me do it. It says that Brandon does not need that. Like, oh my gosh, here you go. In case you don't know how to plug into the calculator. 5, 6, 7, 8, and I'm gonna square. Oh my God, that is mind blown, right? Total mind blown. Okay. Same here. So if I have 1 divided by x and I wanted to substitute in 5, 6, 7, 8, again, put it into the calculator. Now, putting this to the calculator is a little different. When you're putting fractions into the TI-84, if you have a newer one, it makes the fractions. If you have an older one, it does not. So your fraction is your division symbol, and then you just plug it in. That's it. I know, so terrible. The struggle is real. Oh my goodness, you made it. Okay. Questions about plugging into the calculator. Okay. Your other option is if you have multiple values is to graph them. So if you have multiple values, like if it just wasn't 5.678, I would put x squared in and I can hit graph. And when you're in the graph mode, you can also just you would hit second, trace, and value. You see where it says value? That allows you to type in whatever value you're looking for. So 5 and 6, 7, 8 would give me that. So that is your other option as far as calculating. Yeah. If you have more than that, if you have a lot of values that you want to see, the next thing is to use your table. So second graph takes you to the table. And you're going to change your table settings. Instead of having it as independent on auto, you want independent on ask. What this will ask, what this, you heard me, Brendan. What this allows you to do is to type in all the values you need. So if I wanted 5 and 6, 7, 8, and I wanted 6, and I needed 10, and I needed 11, this allows me to create the table of what I need. Okay. Questions about finding the values in the calculator. Okay, so we've gone over using the calculator page, using the graph page, and using the table page. Cool? All right, I'm gonna keep it trucking. Okay, do we need to see more examples or are we good? Okay. All right. So now we're on to implicit form of a function. In general, when a function f is defined by an equation in x and y, we say that that's implicitly defined, okay? It just means that you're not using f. So implicit, notice how there's no f of x. Explicit means you're using f of x. Literally, that's it. Implicit, no f, explicit, and f. Okay, that's literally what the difference. Questions, comments, concerns about implicit form? None? All right. So notice when you're doing the implicit form, you are getting y by itself and then substituting in f of x for y. Okay. So this is a summary of what you should understand. So domain and range of functions, your symbols that may be utilized, function notation, understanding your independent, dependent variable. So yeah. Now, on to the difference quotient of a function. Difference quotient, here's the formula. So remember I said that x plus h was going to come in handy? Here's why the x plus h comes into play. You will see this again if you take calculus. It's just the very beginning introduction of calculus. So we have f of x plus h minus f of x divided by h. This is your difference quotient. Okay. If you're allowed to make a note card for your test and you can't remember this, would this be something you put on your note card? Yes, probably. All right, so applying the difference quotient. So if it says find the difference quotient of each function. So if we have f of x equals x squared minus 1, we're going to substitute in with x plus h. So we're gonna substitute in for where x is with x plus h. And we're gonna use the function as itself. So notice here, you're literally substituting in. And remember, when you have this means x plus h times x plus h. It does not mean distribute the square, right? It means you have a binomial times a binomial, okay? And then you're gonna multiply through. After you multiply through, you're going to combine like terms. So I have a positive x squared and a negative x squared. I have a -1 and a +1. Those combined and eliminated, right? Because they become 0. So I simplify and I'm left with 2xh plus h squared. Can I simplify some more? Yes, I can do what to each term? I can eliminate an h from each term, right?
Yeah.
Because they all have at least one h. So I can eliminate an h and I'm left with 2x plus h. So my difference quotient is 2x plus h. Okay, the difference quotient comes in handy because you're finding your slope, pretty much your rate of change at a given point for this function. When you go to calculus, this is called the derivative. dy over dx. Yeah, so when you go to calculus, you're finding your derivative. And that's where this comes into play. All right, questions about finding the difference quotient. Okay, let's try another one. So if we have f of x equals 1 over x, to find the difference using the difference quotient, remember it's f of x plus h minus f of x divided by h. So I'm going to plug everything in where it goes. So in this first term, it's this, but instead of just an x in the denominator, it is a x plus h, right? So it's going to be 1 over x plus h minus 1 over x all over h. Okay, so if you were a part of that 2020 group of kids in Algebra 2, this is what you missed with rationals. It was at the end. Okay, so when you're adding and subtracting fractions, they must have a what? Common denominator. Fastest way to do this is because they're small denominators is to cross multiply and multiply the denominator. So we have 1 times x, which is x minus x plus 1, x plus h times 1, which is just x plus h. All over x times x plus h. I like to call this chopsticks in a bowl. You should. Yeah, I told you were gonna get there. I know, I was waiting. I was like, they're not gonna tell me they didn't hear this. Here's my chopsticks in a bowl. Does it not look like chopsticks in a bowl?
No.
Whatever, you see the chopsticks and you see it in the bowl. How do you not see the chopsticks in the bowl? No. Who scrambles with 2 sticks?
Oh, you know, looks like a Friday. Like a little like circle in the bottom.
Whatever. We shall continue. All right, so I'm going to distribute the negative. So that gives me x minus h over x times x plus h. What happens to my x's? They cancel out. And I'm left with negative h over x times x plus h. You don't need to. You can if you want. There's no need. It doesn't make a difference in the value. So. All right, let's look at it pretty. So we substitute it in. Then we distribute. Then we continue to distribute. Our H cancel. Oh, wait, I dropped an H, didn't I? Fiddle farts. I dropped one of my values. My bad. Good thing it's typed out. So we substitute all the values in. You didn't tell me? You didn't want to say that to me?
No.
Cool.
Okay. I guess the H doesn't exist.
No, it does. I just dropped it. So forget it. It's not part of the party. I don't know how I did that, but good thing it's typed out. So that is our difference quotient for rational. And again, when you get to calculus, you'll do this, and it's going to be called differential equation. Okay, finding the derivative. Differential, difference. You hear the names? They go together. All right.
You got it wrong.
What? All right, doesn't matter what function you have, this still applies. So finding the derivative, now I'm saying derivative. Difference quotient, this is not calculus. Difference quotient for any function is possible. So notice this time I have the square root function. So as I go through the square root function, I substitute the values in for f of x plus h and f of x. Looking at this right off the bat, the only thing I can do is ratify. So remember, ratifying means that you're multiplying to get rid of the square roots. So notice when you ratify, you multiply by the conjugate. So the conjugate means instead of whatever operation you're doing, you're going to do the opposite. So the conjugate of this is to add. If I multiply the numerator and denominator by the same thing, am I affecting that problem? No, I'm just manipulating the problem because anything divided by itself is one. Okay, so I'm manipulating the problem. And now I would go through and I would multiply. Okay. So when I multiply, this is going to cancel out. I'm going to be left with two of these, which is why they are squared. Okay. So when you are, this is multiplication, right? I appreciate you being honest instead of just sitting there. So I'm going to have 2. So your FOIL. So 2 times 2 square root of x plus h. There's 2 of them, right? And then it doesn't matter about the outside because they're going to eliminate. You're going to have a negative and a positive. So all you're doing is your first and your last of FOIL. So my first 2 terms and then my last 2 terms time each other. Because if we remember difference of 2 squares, so difference of 2 squares, if you have a plus b times a minus b, it's going to equal a squared minus b squared. I have difference of 2 squares. I have a plus b sich, a minus b. So all that matters is your first term and your last term. So you don't actually have to FOIL if you utilize your rules. Yes, no? Okay, where's the no at still? This right here, this is from our quadratic factoring. Because of this rule, if I distribute this, if I was to go through and do all of FOIL, let me do all of FOIL for you. First, right? Outside, inside, and last. What happens to the middle terms? They cancel out. So this is why it became a rule, because no matter what, your middle terms are going to do what? They're going to cancel out. That's why it's just the first and the last. I'm pretty positive I just showed you.
Yeah.
Yes. Why did the -2 become a +2? Because you have a negative and a positive. And what does a negative times a positive make? You got the blue line, the conjugate, because you want to cancel out the middle. You're trying to get rid of the radical signs. So anytime you're trying to get rid of a radical, you just do the opposite of it. So what happens here is that I have this square, which I can distribute. And a square times a square does what? A square root times a square. Say that better. It eliminates, right? Because they're inverse operations. So what this allows me to do is get rid of that. And I no longer have those radicals in the numerator. Because that's what this represents. And then once you combine like terms, all you're left with is 4h. Because you got to distribute. And then you'll have a positive 4x and a negative 4x, and they're going to cancel out. And you're left with 4h in the numerator. And then your h's are going to cancel out. That h comes from distribution of the h's. And then this is your difference quotient. The square root would be the most complicated because you'd have to pay attention to the conjugate. But it would be the most complicated. Yeah, they'll be on your homework. You can look up Khan Academy for anything you want. Yeah, I can't control what you Google. Oh, no, I'm not. Oh, do I want to assign work out of Khan Academy? No. Why? So I have to create a Google Classroom and then I'll have to, no. We already have a platform. Sticking to one. All right. So again, square root is the hardest. That's why we build up to it. And definitely takes a little practice. So look over it, ask questions. I'll gladly work it out again if you come to tutorials or on Friday if you need it. Just let me know. All right, domain and of functions. So the domain and the function is the set of real numbers that will work for that function, right? That's what your domain is, the set of numbers that will work for that function. We're just gonna basically zoom through this. So here I have x squared plus 1. So looking at x squared, I'm gonna identify its parent function. What is the parent function? Well, the parent function is quadratic, which is f of x equals x squared. What is the domain of the parent function? Negative infinity to positive infinity. It's all real numbers. So guess what the domain of this is? It's going to be the same thing. It's going to be all real numbers because you're going to still match your parent function. Okay, so you're going to have certain attributes of your parent functions that are going to follow you through. Just like genetics, you have certain attributes of your parents that follow you through, right? Same thing with functions. All right, let's look at another one. This guy, what is this one? What would be its parent function? Parent function would be the 1 over x, would be the rational. Okay, with the rational, we know that there are some asymptotes, right? There are domain restrictions. So with this parent function is from negative infinity to 0, union 0 to infinity, correct? That's because x cannot equal 0. So therefore, there's a domain restriction here. My domain restriction comes from the denominator. You remember that? The restriction comes from the denominator. So x squared minus 25 cannot equal 0. So what can x not be? X cannot equal positive 5 and X cannot equal negative 5. Because either one of these would make it equal to 0. Do we see that? Those are your restrictions on your domain. Okay, so again, why did we do that? Division by 0 is not defined, so our denominator cannot be 0. So therefore, X cannot equal negative 5 or 5. Okay, how you write it? If you're writing in set notation, you're just saying X such that X cannot equal negative 5, comma, X can equal 5, right? This is in set notation. Notation. And then I don't think I wrote interval. And then your interval notation would be from negative infinity to negative 5, union, negative 5 to positive 5, union, 5 to infinity. That would be your interval notation. Okay. So again, the first thing you need to identify is the parent function and think of the behaviors of that parent function, because that's what the domain would relate to, is what are the behaviors of the parent function. All right, let's look at the square root. Obviously, its parent function is f of x equals square root of x. And we know that x has to be greater than or equal to 0, right? Yes. So that's our domain restriction for square root, is that x has to be greater than or equal to 0. So when I look here for this t, I know that f minus ft has to be greater than or equal to 0. So t can't be any number. What can it be? So t can be any number greater than or equal to 1. Because that's what would make this a true statement, right? Yay, nay? Do we see why we said that?
Yeah.
Okay, so again, the reason is the square root of 5 minus 5t. You can't have non-negative numbers underneath a real square root. And because of that, 5 minus 5t has to be greater than or equal to 0. And therefore, t has to be greater than or equal to 1. Oh, I wrote it backwards. Shitty. I divided by a negative. I'm slacking. I know. Remember, divide by a negative, flip the switch. I did. I divided by negative 5. It only switches when you divide or multiply by a negative. T has to be less than or equal to 1. So that would be my domain restriction for this problem. All right. If I'm going to write it as a set notation, notice this is the set, and here is my interval. I thought I wrote interval on the last one, but I guess I did it. I wrote it on this one though, so it's there. Okay, notice it's a bracket, not a parenthesis, because of it's equal to. All right, so you would continue doing this. Again, this is related to rational. So we know that there's going to be a restriction, okay? There's also another restriction because there is a square root, right? So this function not only has one restriction, but 2, okay? So for the first one, the 2x plus 6 has to be greater than or equal to 0, right? So x is greater than or equal to -3. For the second, the denominator, it cannot equal 0. So x cannot equal 2. So I have 2 restrictions that I have to acknowledge in order for this to even possibly give me real values. Okay, So what that means is that I have an asymptote and a function that continues. Okay, so written, did I write the interval? I did not write the interval, dang it. So here, I start at -3, I go to 2, stop at 2, and then after 2, I continue to infinity. And that would be my interval. Because I cannot equal 2, so that's my bump in the road. That's where I have to stop and then resume. All right, so main restrictions, rational and square roots, right? Under square root must be greater than or equal to 0, and the denominator cannot equal 0. All right, so paying attention to these is the summary of it all. As far as what to pay attention to, as far as the domain, feel free to read over it. And then the last are just word problems. So using your restrictions and working through the word problem, it's just a word problem example. Putting it all together. So when you're finding the sum and difference, you literally are combining the two functions. When you're finding the difference, you are combining, distributing the negative and then combining. When you're multiplying, you're multiplying. And when you're dividing, you're simply simplifying. Okay, so these are all the rules for that. So as you navigate through, how can you multiply, add, and or subtract the given functions? So we have f of x equals 2 over x plus 3, g of x equals x over x minus 4. So if I want to add the two functions together, what do? So I'm going to add the two functions. Notice that I've already stated my restrictions. And my restrictions exist because of the denominators, right? Okay, so my restrictions are here, boom, 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 for those two functions. Now, when they become friends, so if I want to add them together, it looks like this: 2 over x plus 3 plus x over x minus 4. Because they are fractions, they must have what in order to be multiplied together? A common denominator. So I'm going to multiply this guy by x minus 4 and this guy by x plus 3 to create a common denominator. Do we see that? Okay, now that they have a common denominator, I can go ahead and combine, distribute, and combine them into one fraction. So I distribute my coefficients and variable. And now I'm going to combine like terms. So that's 2x and 3x. Like terms have been combined. I can do nothing else. So therefore, my domain is both of them. So my domain did not change. X still cannot equal 3 and x still cannot equal 4. So my domain is joined. Forget how long 3.1 is. Such a long section. Huh? It's filled with so much stuff. Okay. Well, I'm always worried that I don't give you enough examples. So there's a lot of things that can happen with 3.1. So I give you every example of what could happen in 3.1. And so same thing with subtraction. Again, denominators aren't the same. So what are we going to do? Multiply. So we multiply, so we have a common denominator. Notice this time, you're going to distribute your negative. So when you're distributing the x, it's actually going to be a negative x, okay? Because it's subtraction. So you distribute the negative, combine like terms, continue it through. Here's your final answer, okay? Your negative can either be in the front. Notice how I factored it out and put it in the front. It can be part of it. I really don't care. And my domain did not change. It's still the joint domain because my denominator still can't equal 0. Okay. Gesundheit. Okay, we have 2 minutes left. Let's see if we can get through this. Multiplying. Okay, when you're multiplying two fractions, remember it's numerator times numerator, denominator times denominator. Does that sound about right? Numerator times numerator, denominator times denominator leads me to 2x times x plus 3 times x minus 4. And I will not make you distribute your denominator. Doesn't serve you any purpose, doesn't make it any better. So that's where you would stop at. And then define the domain. And again, x still cannot equal -3 and x still can't equal 4. Because it would make my denominator what? 0. Okay, and then multiplication, division. So you put f of x divided by g of x. So I end up with a double decker. Okay, when we divide fractions, we are multiplying by the reciprocal. So we multiply by the reciprocal. Now it's just a multiplication problem. And again, with multiplication, it's numerator times numerator, denominator times denominator. So this time, my domain has finally changed. So my domain, I have an x and I have x plus 3. So x cannot equal 0 and x cannot equal -3. And originally, because of the original problem, you still maintain the fact that x cannot equal 4. Because if it was 4 in the beginning, then this would never ever take place. So we added on to our domain restriction. Okay, and that's it. Bye.